Hello, my name is Sam Doran. I'm an engineer that works on the TripleO team at Red Hat, and today I would like to talk to you about a new Ansible role that we've written to make life a little easier for managing clouds, OpenStack clouds that have been deployed with TripleO. So here's a brief overview of the things that we're going to cover today. Basically, the capabilities of the role as it exists today. It's not to say it couldn't be expanded in the future, but this is what it does today. So the first thing we're going to show is how you can use this role to easily fetch logs from your deployed overcloud nodes. So say you just want to grab all the logs for quick troubleshooting, or you need to look for a specific string of text in the logs on all your systems, and you just want to pull those back for further analysis onto your undercloud node. You can do that really easily using this role. The next thing we'll talk about is how you can restart services using this role. So service restarting is kind of tough in OpenStack because a service is not just a single container or a single daemon. It could be multiple things. And it could be containerized, meaning it could be a container that needs to be restarted, or it could be a service that needs to be restarted. The names of those things vary. So we have a nice way to do that in this role that makes it very simple to just pass in a single service name, and the role will figure out if it's containerized or if it's a systemd service that needs to restart and just do the work of doing that. And the last thing this role does is makes it a little easier to do container cleanup. So dead or stopped or exited containers, dangling volumes, dead images, things like that, those can take up disk space over time. So this role makes it really easy to periodically run and clean up all those things. By default, it cleans up the dead, exited stuff, dangling containers or dangling volumes. But you can pass in custom filters if you want to make it do different things that you want it to have it clean up. So let's get into showing two shells open here. The left is my undercloud node, and the right is my overcloud. And what I would like to do first is just go ahead and run this basic playbook to fetch logs. In the later two things I'm going to show, I'm actually going to run some tasks over on the overcloud node to show you the container cleanup and show you some other things that are happening. But for right now, for just fetching logs, we don't really need to do that. Actually, before I get into that, let me show you what this role actually looks like. So where we are right now is we're in our TripleO Ansible project repository, and this has a few playbooks in it. So the playbook we're going to run first is our fetch logs playbook. So this is a very simple playbook. It's going to target our hosts and inventory, and it's going to call the OpenStack operations role running the fetch logs tasks. So if we want, we can look and see what that looks like. Let's go up one directory and we'll look at our actual role. Go into tasks and fetch logs. And this is the actual task that this playbook calls. And you'll see that it takes a ton of variables, and it has some defaults that essentially grab everything from var log that ends in star.log. But we can pass in things like contains string. So if we wanted to get only the logs that have this string of text in them, if you're looking for like a UID or a specific failure message or something like that, you could pass that in as well. But in the default state, this essentially just grabs all the logs off of a target system and pulls it back to the control node. So let's go ahead and run this. This might take a little while to run because it's going to pull a whole bunch of logs. We only have one overcloud node in this instance. So we can see right now it's just finding all the logs in var log that have star.log at the end, and it's copying them to the control node. And the way that the fetch module works is it by default maintains the hierarchy. So it's going to put it in a top level folder that's named the inventory host name. In this case, it's an IP address. And then it's going to keep the same, var log, whatever folder or directory hierarchy inside of that folder. So it makes it, essentially look the same as if you were on the file system of that node after it pulls all those logs back. All right, so it's finished. So now if we go look at this directory, we'll see we've got var log containers, var log containers nova. We have all the logs just as they appear on the system. All right, yay, log files. Okay, so say we didn't want all those logs, we only wanted a small subset of that. So go ahead and just clean that up. I can actually specify, okay, for my operations logs, the role is looking for a variable called operations logs. What paths do I want to search and what patterns, and do I want to recurse in this directory? So in this case, I'm going to just look for the files in var log containers. So now if I run that same playbook, but I just pass in those variables that say, hey, basically give me a different set of logs, and we let this run, hopefully it'll be a little faster because it's fetching fewer logs, but it will also, it would help if I did a -e for extra vars. It'll also run a little faster, but then it'll only grab the logs in var log containers. Again, I think the most powerful part of this is probably going to be passing in a contains string. So if you're looking for logs with a particular string in them, much like grepping for logs on remote systems, you can kind of have Ansible pre-grep for you. Only give me the files that contain the string, pull them back to your control node for further grepping and spelunking. All right, and you see that was a little faster because it pulled fewer logs. So now if we look at that, you can see we've only got var log containers. All right. So the next thing I want to look at is container cleanup. So the role supports multiple container runtimes. The default is Docker, but in the future we'll have Podman support as well, after we have some Podman modules written that I'm currently working on. So if we look at our container cleanup playbook, again, we're calling the same role, our OpenStack operations role, but this time we're using the container cleanup task file. So if we look at, let's see, we look at our operations role, and we look at tasks, and we look at our container cleanup tasks file, we can see, okay, this is pointing at our container runtime, which in this case, it's going to default to Docker. So we're going to look at the Docker one. And this is going to do a couple of things. The first thing is it's going to use a custom module included with this role called Docker Facts, which accepts 3 filters: image, volume, and container filters. And what this facts module does is return a list of UIDs that get passed into the subsequent modules. And it's going to remove all of the things that it finds, basically. So we pass in 3 different filters. Our Docker Facts module returns the output of those as lists. And then we've got 3 tasks that clean up images, clean up containers, and clean up volumes. And if we wanted to look at, what are those default filters, we could go up. We can just look at defaults. And those are the default filters for the role. But again, we could change those to anything we want. So in its default state, it basically cleans up like the normal container cruft. All right, so over here, I'm going to have a command running. It's basically going to show us, all right, how many, dead cleaned up things do we have? So we've got 43 dead or exited containers that we need to clean up. All right, so I'm going to run this, and you can actually run this in check mode if you want to see what would it do before you actually let it loose and let it start deleting things. So the first thing the task does is it looks at the system and it finds containers, images, and volumes that match the filters we passed in. And you can see that remove images didn't do anything because we didn't have any images that match our filter. Containers, looks like we've got some things that are matching that filter. So if this was actually running live, you would see the number on the right be going down as those things get deleted. But since it's running in check mode, it's just reporting a change, but not actually making the change. All right, now if we run that for real, it is actually going to perform all those things that it said it would do. So this has a sanity check at the beginning that ensures that whatever container runtime you specified, Podman or Docker, that actually is a valid container runtime. And so now we can see it's removing the containers, and we can see that number on the right is going down as things get cleaned up. So this is now performing actual container cleanup. All right, so we can see that it did indeed clean up our containers. All right, so the last thing that I wanted to show that this role does are service restarts. Now, service restarts in OpenStack can be particularly challenging because a service could be containerized or running as a standard service managed by systemd, or a service could actually be a collection of specific containers or a collection of daemons that need to be restarted. And it's incredibly arduous to figure out, okay, I need to restart service X, but that actually means I need to restart these 3 containers, or I need to restart these 3 daemons, and I don't know which systems those daemons are necessarily running on or which containers those are necessarily running on. So this role kind of abstracts all of that away, does all of the decision making for you, figures out, okay, the operator said I want to restart service X, and I know that I have containers. So this service consists of these containers or these unit files. It looks at the system and says, do you have those containers running, or do you have those unit files? And it does the right thing based on which one it finds. And let me show you how that works. So if we go look at well, first we'll just look at the playbook, which is pretty straightforward. We're just calling the OpenStack operations role, but this time we're calling the restart service tasks. So now if we go look at our operations role, go look at our tasks file, look at restart service. So this is also leveraging another custom module included with this role. And what it does is it takes a list of services that you as the operator want to restart, and it also, but the service map is essentially a dictionary that maps the list of services you pass in and says these are the container names and these are the systemd unit file names for that particular service. So you can just pass in a container name and the role will figure out the correct container names, or it'll figure out the correct unit file name. So then we either restart a container or we restart a service. So we use the Docker container module if we've got Docker containers to restart. So that's an output from the service map facts, and then we restart the services with the output of systemd services to restart. So let me show you what the default service map is. So this ships with a service map in vars main.yaml. Mainly because this, it's not in defaults because it's not meant to be completely overridden. So these are shipped as predefined service names. These are the names of the containers. These are the names of the services as they ship when installed with TripleO. So you can, for instance, say I want to restart, Cinder, and it has systemd units and container names. And what this role is going to do is it's going to look for those systemd units, and it's going to look for those container names, and it's going to return whichever one it finds, and it's going to either restart the containers or restart the particular service. If you have custom services, one of the things that's really nice about this role is you can layer those in pretty easily. So if we go back to our tasks file and we look at what this is doing, you'll see this service map line. It combines the operations service map with operations custom service map. And we'll show you what that looks like in our demo. So if you have things in addition to the standard normal services, you can layer those in very easily by defining your own service map, which is essentially a key that has, here are the systemd unit names and the Docker container names. So it allows you to extend this fairly easily to add in your own services if you have those. All right, so what I'm going to do, so in its default state, this doesn't restart any services. So you have to, at a minimum, pass in a list of services to restart. So we're going to start by just restarting the glance service. All right, so ignore the bottom few lines for now. Right now we're going to pass in to the role a list of services to restart, and in this case it's going to be glance. So over here on my right terminal, we're going to watch this running container and see it has been up for 57 minutes because I've been playing around with this and restarting it a few times. All right, so we'll go ahead and run this playbook. And we're going to pass in our variables, which has our list of services that need to be restarted. You can see that it restarted the containerized service. But when it said restart OpenStack services, it skipped because there is no OpenStack Glance API service on the node. All right. Now, if we go and say we want to add in like a custom service. So for the sake of this demo, I just picked here is a service I have on the system. I know we've got cron installed. That's not an OpenStack service, but it is a service that's managed by systemd. So I'm going to go ahead and just in this bottom window, I'm going to show you, okay, this is how long the cron service has been active. It's been active for 59 minutes. So when I want to define a custom service map, I just define a dictionary. The keys are the name of the service. This can be anything because that's the key name is what you pass into the role in the list. The systemd unit and container name, these need to be either the name of the unit file or the name of the container, because essentially what the custom module is doing is looking through all of the unit files for this string, or it's looking through all the container names for whatever string you put in container name. All right. So now up here, I need to pass in, okay, the cron D service is a service I want started. And the role is going to inspect the system, and it's going to look for these systemd units and these container names. I don't have any containers, so I just pass in an empty list. And before I run that, I have some debug statements in here that I'm going to remove. All right. So now if we go and rerun this playbook, passing in our extra variables, which this time it has a custom service map defined, which basically says, hey, I want to restart cron, and the name of the cron systemd file is cron D. If that's present on the system, I want to restart that. didn't pass any container names for it, so it's not going to try to restart any containers. And so now if you watch the right pane while this is running, you'll see it's going to restart Glance as a containerized service, and on the bottom it's going to restart cron as a systemd service. All right, and you can see that it restarted both of those services. So again, I think this is probably one of the coolest features of this role, is it takes something in OpenStack that's really problematic and it abstracts it away, so you can define, here's the list of systemd units, here's the list of container names, and then all you have to feed to the role is the service name, and it will figure out, is it containerized or is it running bare metal, and it'll just do the right thing. It'll restart the container, or it'll restart the service. So that's all I have today for the demo of the OpenStack operations role. I look forward to people using it, giving us feedback, and hopefully contributing. That would be fantastic, and I do hope that this makes managing your OpenStack clouds deployed with TripleO that much easier. Thanks.